Have you ever wanted to build your own digital thermometer? You know, a device that can see the world in degrees Celsius using just a couple of simple parts? Well, today we're doing exactly that. We're going to take these components and turn them into a live, real-time temperature sensor. So let's dive right in.
So here's what we're working with. An Arduino, which is going to be the brain of our operation, this tiny little temperature sensor module, and of course, a few jumper wires to hook it all up. Our goal is super simple. Wire them up, upload a tiny bit of code, and then watch that live temperature data stream right onto your screen. It's a really fantastic way to get your feet wet in the world of environmental sensing.
All right, first things first, let's get properly introduced to the star of our show, the sensor that's going to be doing all the heavy lifting.
This little guy right here is the DS18B20. It's a super precise digital thermometer. Now, it doesn't just give you a vague idea of the temperature, it spits out a hard digital number. And the cool part is you can actually choose how precise that number is, anywhere from 9 to 12 bits. Think of it like the resolution on a camera. 9 bits might tell you it's 23.5 degrees, but 12 bits, that could give you 23.5625 degrees. So more bits just means you get a much more detailed picture of the temperature.
And get this thing is tough. It can measure temperatures from a scorching 125 degrees Celsius all the way down to a freezing -55. That's a huge range, and in the kind of temperatures we actually live in, it's accurate to within half a degree. That's just incredible precision from such a tiny little component.
Now, what's really interesting about this sensor is how it talks to our Arduino. It uses something called the one-wire bus protocol. And, you know, the name kind of gives it away. It's a communication system that's designed to be as simple as possible.
And here's where it gets really clever. With this one-wire protocol, you don't need separate wires for data and for power. It can actually handle both over a single line. It even has this wild feature called parasite power mode, where the sensor literally just sips the tiny amount of power it needs right from the data line itself. This is what makes the wiring just ridiculously simple.
Okay, so you might be thinking, what happens if I want to use more than one sensor? Well, this is where the magic really happens. Every single DS18B20 sensor has a totally unique 64-bit address burned into it at the factory. It's like a permanent, unchangeable name. And what that means is you can hook up dozens of these things to the exact same wire, and the Arduino can just call out to each one by name to get a reading. This is an absolute game changer for building powerful sensor networks with hardly any wiring.
All right, enough of the theory. Let's get our hands dirty and actually connect the hardware and build the circuit.
And here is our control center, the Arduino Uno. This is the brain of our entire operation. It's what's going to send out requests to the sensor, listen for the temperature data coming back, and then show that information to us so we can actually see it.
Honestly, the wiring could not be simpler. We've got 3 pins on our sensor module. The ground pin, that's the one marked G and D, that connects to the ground pin on the Arduino. Easy. The middle pin, marked +V, connects to the 5-volt pin. And finally, the signal pin connects to one of the digital pins on the Arduino. We're going to use pin number 4 for this. And that's it. Seriously, the hardware is completely done.
So, with our circuit all wired up, it is time to bring this thing to life. We need to upload a simple program, or as it's called in the Arduino world, a sketch, to tell the hardware what to do.
Now, we could try to write all the code from scratch, but why reinvent the wheel, right? We're going to use 2 pre-written libraries that'll make our lives so much easier. Just think of them as toolkits. The one-wire library handles all that complex communication stuff, and the Dallas temperature library gives us super simple commands to just read the temperature. You can install both of these right from the Arduino software's library manager. It takes just a few clicks.
Okay, let's take a quick look at the code, starting with the setup function. This part only runs one time, right when the Arduino first powers on, and we're just telling it 3 things. First, hey, use those toolkits we just installed. Second, the sensor is plugged into digital pin 4. And third, get ready to send data to the computer so we can see it. That's it, all the prep work is done. And now we're at the main loop. This is the part of the code that will run over and over and over again forever. And it's just this beautifully simple cycle. Tell the sensor, hey, take a new reading. Then print that reading to the screen. Then just wait for 1 second. And then repeat. That's all there is to it. This simple loop is what gives us our non-stop stream of data.
So, the hardware is wired up, the software is written, there's only one thing left to do. Let's upload this code and see our thermometer in action. This is the moment of truth.
Okay, code's uploaded. Let's see if it actually works.
We just open up the serial monitor in the Arduino software. And there it is, a live continuous stream of temperature data, updating every single second. It works. We've just successfully built a working digital thermometer. How cool is that?
So there you have it. We went from a pile of components to a fully functional device. But you know what? This is really just the beginning. Let's talk about where you can take this from here.
You have now officially mastered the basics of reading a precision digital sensor. That's awesome. But what's next? Remember that unique 64-bit ID we talked about earlier? Now's the time to actually use it. Try adding a second sensor, or even a third, to that exact same wire. With just a tiny tweak to the code, you can start monitoring the temperature in multiple places all at once.
And you know, this is the most important takeaway. Measuring data is just the first step. The next, more exciting step is using that data to make decisions. You could turn on a fan if a room gets too hot, or turn on a heater if it gets too cold. So the real question I want to leave you with is, now that you know how to measure temperature, what are you going to control with?